This week I've been playing around with an animated counter built with Framer Motion. Had a lot of fun building it. There's a lot of directions I want to take it, but I had to kind of pause my progress and make this video and show you how far I got because it's a lot of fun and I think you'll be able to take this code and run with it yourself and have some fun with it. So here is what we are starting out with. We've got a simple client-side React component. It just has a little number range. It sets the count with this input field, and we are going to be working right down here with this counter component. And the goal is to make it animate in response to changes in this React state. So first, let's come here to where we're rendering the value. And instead, I am going to print out a range of digits from 0 to 9. So I'll just make this a span, and then we'll just print in the digit right here. Now this div is relative, so let's make this span absolute and set 0. And then we'll make it flex, justify, center, and that will kind of center the number in the box. So if we just had 1, we'll see it prints out 0. 2, we'll see 0 and 1 are kind of right on top of each other. And we want to print these out in a vertical line right here so that we can animate them up and down. So let's go ahead and make a new component for each one of these numbers. We'll call it number. And we'll return our span tag. We'll expose a number prop, which is just going to be type number. We'll render that right here. We don't need the key anymore, and we can replace this with number, and we'll pass in our index as our number. Okay, so we're back to where we started. And now to space these out and to actually animate these, our strategy is going to be to use a framer motion. So we're going to turn this span into a framer motion. And when we do that, we can actually set the Y prop right here. So if we were to set this to 10 or 20, we'll see that moves it up and down. It's just using a transform to do that. These boxes right here are actually 24 pixels, which is just from the line height. So if we were to set the Y prop to our number times 24, then we should get a nice offset. And if we bring back all 10 digits, there we go. So this is a nice starting point, and the idea here is going to be to move these as this state changes. Now to actually animate a value in Framer Motion, we need a motion value. And in particular, we want to use a spring because that's going to kind of make this animation fun. So we'll default our spring to the value of the React state we pass in, and this is going to give us an animated value. And we can update this every time the value changes inside of an effect. So we can call animated value.set to the new value every time that value changes. And we want to do this in effect because the whole point of Framer Motion is to animate outside of React renders. So with any luck, we now have an animated value that kind of tracks the value of our count state. And to prove it, let's just turn this div into a motion.div, and we'll set the style property of Y to our animated value. And now, check this out. This is actually moving it up by the pixel value, but if I jump, you'll see it has a nice spring animation to it. So pretty neat, pretty easy to do. And hopefully you can see where we're going with this. We want to animate each one of these digits individually instead of animating this parent container. So let's turn this back into a div, and let's go ahead and pass our new motion value into our number component. So we'll expose a new prop, MV. This is going to be type motion value, straight from Framer Motion. And now we have this motion value. Now we can't just use this right here in our render function because number is React state and MV is a motion value which updates outside of render. So in order to combine these two things, we need to use a transform. And this will give us our new Y prop, which we'll set on our style. Now transform takes in a motion value and it yields out the latest into a function that we can use to calculate our derived property of Y. So if we save this, we'll see our styles over here reset. Let's just put back what we had before, return 24 times the number, and that should spread them out. And now we can work with the latest version of the motion value. So what do we want to do when we go up to 1? Well, we want all of these to slide up by 24 pixels. So if we just subtract 0 minus 1 will give us -1, 1 minus 1 will give us 0, 2 minus 1 will give us 1. So we should be able to say number minus latest, get that difference, and check this out. Pretty cool, right? We're just subtracting the latest value of our animated motion value from the digit, and everything is sliding up and down perfectly. So let's just parameterize this to make it a little bit easier to understand. We've got the height is 24, and then we calculate this offset, which is number minus latest, and we return the offset times the height. Everything still works great. Okay, here's where it gets a little fun. So the idea with having this work as the number goes kind of past 9 is to reuse these span tags, basically reposition them down below once they get past a certain threshold. So if we go down to 0, we see everything starts out in a row here. But if we could move 6, 7, 8, and 9 from down here kind of to up here, we'd have our number line centered around the square. And then every time we increment by 1, we basically move 1 from the top of the line back down to the bottom, and we keep doing that as we increment the number. So to start, let's just say that any number that is kind of greater than 5 here has an offset that is greater than 5. We want to move these up by this amount. So let's get our current value here as a memo. And then if the offset is greater than 5, well, what do we want to do here? We actually just want to shift the current place up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units of the height, right? Because the 9 should be showing up right here above the 0. So we can subtract off 10 units of our height from our memo for all those numbers past 5. And then if we return the memo, look at that. 6, 7, 8, 9, right above 0. And if we go up to 1, we see 6 kind of flips over right when it gets past that threshold. Pretty neat, right? So this is kind of how you can see a sort of infinite scrolling mechanism happening here. And pretty amazing how performant this is, kind of how easy this is. We just have a little bit more work to do to get this to repeat past 9. But this is pretty neat. I was pretty excited to see this in action the first time I pulled this off. So let's talk about what happens when we get past 9. So if we go to 9, things look okay. And then if we go to 10, right here, we really want this 0 to come back around, because this is really just the ones place of our number. So we want these to kind of loop around and around as the number goes up, right? And even if we were on 20, we can see it just kind of keeps going up. And that comes from this calculation right here, our offset. So when our state is 20, for our 0 number, this is going to be 0 minus 20, which is negative 20. And that's why we get all these pixels way up here. We don't actually want to calculate the absolute offset between the latest value of our state and our digit. We want to calculate just what the ones place is in that number, right? So we need to use modulo. Let's create a new variable called place value, and we'll just take latest modulo 10. And if you haven't seen modulo before, it kind of gives you the remainder. So 5 modulo 10 is 5, but so is 15. And so this is a handy way kind of to get the ones place of any number. And now instead of using latest to calculate our offset, if we use our new place value, check that out. It looks like the correct number is in the box. When we get to 10, it does kind of wrap around. So the right number is showing up in the box, but we have a little bit more work to do here because we want these to be shuffling every time we get past that threshold. So if we're on 9 right here, the 0 should definitely be right after it. Well, what is our offset for 0 when the latest is 19? This place value is going to be 9 because that's the ones digit of 19. 0 minus 9 is negative 9. And we can see here we're kind of doing our wrapping adjustment based on whether the offset is greater than +5. So we can see that these offsets are all negatives kind of until we loop back around. If we just added 10 to this, that's going to kind of flip this around from -9 to +1. Well, this will actually fix 0, 1, 2, and 3. We can see that they come perfectly down where they're supposed to be. Now let's go up from 19 to 20. And at 20, we have this problem where 9 should be right above the 0. Well, what is 9 minus 0? That's 9. Plus 10 is 19. But we want this offset to be between 0 and 9. So if we just wrap this calculation and use modulus on 10 again, check this out. 21, 30. And this is pretty awesome. 10, 15, 50. Everything's shifting around. We just basically had to use modulo a few places to kind of get this to repeat, but how fun is this? And I love how responsive this is. The spring right here is taking care of kind of interruptions and keeping momentum. So if you hold it, it works. If you change it a lot, it works great. And this is always displaying the ones digit of the number in our state. So let's go ahead and duplicate this. Now we've got two little number counters here, but we want this left one to represent the tens place. So let's add a new prop to our number place. And this one will be the tens place. This one will be the ones. We'll add place as a prop. And then right here where we calculate the place value, let's just divide this by the place that we pass in. Check this out. I could just stare at this all day. Let's add one for hundreds. And we'll pass in 100 right here. Pretty cool, right? Let's go ahead and come to our ring, add overflow hidden. And there you go. You got a little animated counter. 0, 10, 100. Responds to state changes. And it actually has this fun property where, these move proportionally along as we're going. My next step here was going to be to make it so they only flip once the place value actually changes instead of moving proportionally along. But I thought this was such a fun effect, and I just wanted to show you kind of how far I got when I was working on this yesterday. And I just think this is so rad. I love that you just basically render a counter and you pass in some React state, and Framer Motion takes care of the rest. We're just updating this spring value outside of render, and everything else is basically derived from that. We have this little transform right here that we use to animate the Y prop on this motion span. I mean, that's about all there is to it. And you could imagine doing so many cool things with this. Imagine if we didn't have the overflow hidden right here, and we used some Z transforms or 3D transforms. I've never actually done that, and make them kind of go back just like the counter on iOS. So you could keep these always visible. But I love just how easy it was to make this kind of infinite counter and just to reuse them just through this kind of little shuffling method. You could add some like flip animations where instead of going up and down, right, instead of animating this Y property, maybe you just make them kind of flip like a flipboard as they go through. I think there's so much cool stuff you could do with this, but that is basically the core technique. That's where I landed on just working on this. And I figured you could take this and run with it. So I'm definitely be doing some more experimenting with this, but hope you found that helpful. Have some fun with it. Check for a link in the description to the code. And otherwise, that's it for this one. I'll see you next week.